Barbara, you don't have Joe's like cell phone number, do you? I don't have it. Zoom is always
I just emailed him. I'll see if I
okay.
can find his phone.
His number was in one of the emails he sent us.
Okay. Thanks. Just it's always tricky on Zoom. Getting people to get on.
This might be a hard one to get people on. Getting used to the invites and all that.
Well, I just texted him. Let's see. I think he's coming.
Hey, guys.
Hi, Joe.
Hey, guys. How you doing?
Good.
Good.
I had to use my wife's computer. My other computers is not working great today. You guys can hear me, right?
Yep.
Yes.
Yes.
Beautiful. Beautiful. How's everybody?
Good.
I got it. All right. Do we have a quorum?
Yes.
We do. Fantastic. All right. Let's call to order. Barbara, do
So,
you want
hold on.
to?
Paul needs to start the recording. Now you're set, Joe.
Okay. Do you want to do a roll call, Barbara?
Joe Costa,
Here.
J.C. Sinelli,
Here.
Bill Mecca,
Here.
Fran Basbigil,
Here.
Ann Sather,
Here.
John Morello,
Here.
Bob Gerbert,
Here.
and Jeff Alterman is not here, and Andrew is not here.
Okay. Let's do the Pledge of Allegiance. I do have a flag. I don't know if you guys have a flag in your own homes. I hope you do.
That's awesome.
I'm going to stand up and pledge the flag. Okay. You guys ready? Pledge allegiance to the flag of the United States of America
and to the
Republic for which it
which
stands,
one nation
under God, indivisible, with
liberty and justice for all.
Trust me, I have a bigger flag in the house.
I have one too, Joe. My husband
You
just
got
handed
one?
this to me.
All right. So could I get a motion to approve the minutes from June 24th?
Motion to move the minutes.
Okay. So who is that by and seconded?
Oh, Ann's motioned.
Okay. Second by JC?
Sure. Second.
Beautiful. Okay. Any comments? All in favor, say aye.
Aye.
Opposed? No one. Abstentions? No one? Motion carries. All right. Do we have any public comment tonight? Hearing none, let's move on to the next. Are there any invoices that we need to review and approve tonight? Barbara?
I did not receive any, no.
Okay. I know that Arcadis is working with accounting to try to get those set up so that when we do receive invoices, we'll be able to process them in a timely manner. Okay. Let's talk about new business. Taisu Kim, you guys want to give a little update on what you've been doing the last 2 weeks?
Certainly happy to. Good evening, everyone. Michael Scott, TSKP Studio, Willis Street, Hartford. With me tonight is Randall and also Ben Klein Cratch from CMTA. Ben will take the bulk of the presentation tonight, but I will start with a brief update on some of the items that I track with you every time that we're together. Ben, do you mind sharing your screen?
Absolutely.
So work is progressing. We're doing quite a bit of the site reconnaissance that we were hoping to get done over the summer while the kids away. That's when we make hay. That's what our civil guys always tell me. But next slide, please, Ben. So today, what I'm going to do is just update you on those tasks that we're tracking, and then, like I mentioned before, hand over a bulk of this to Ben about HVAC. So next slide, please. We know that the traffic counts have been performed and that model has been created. We're waiting for the survey to be complete. Langen issued for us a draft survey that we have started to site the building on. It's really the lower third of the site, sort of that lower southwest corner of that overall campus. Langen is targeting geotechnical the third week of July. So that'll be in 2 weeks. We'll have a rig out on site and we'll coordinate with Trumbull facilities for that access. The other thing that's interesting is for the inventorying and testing for hazardous materials in and around the existing building. Langen's team did have an opening for their crew. They're on another commitment. That deadline has shifted. So we have a window as early as next week that they could get mobilized. So we reached out to Trumbull Public School facilities late this afternoon. Hopefully we can coordinate that and get our crews in the building to go from place to place and get that working. So that's where we are. In the meantime, the design team continues to refine those layouts that we reviewed with you last meeting. That's sort of modified. I think we ended up with a modified option 6. And we're shaking the trees and getting all of our consultants moving. Are there any questions about these items?
Yeah,
All
Mike,
right,
I've got one.
yes.
Mike, I've got one question. It has to do with the schedule to complete the geotech. Is that the start or the completion date that I see there?
I think they'll be out there currently for 2 days, although they can expand that out if they need to.
Okay, so it's relatively quickly.
Mm-hmm.
Okay, fantastic. Thank you.
Okay. All right, Ben, I'll hand it over to you now. All right.
All righty. Good afternoon, everybody. My name is Ben Kleincroft. People know me as Ben KK, if you want to call me that. I am a mechanical engineer that has been working on high-performance zero-energy schools for about 5 or 6 years now. And Today we're going to be discussing HVAC system selection. So thank you for spending your Tuesday night with me to talk all things HVAC. I know it's everyone's favorite topic, but hopefully we can, we can learn something today, and we can maybe find a new system selection for tonight. So we'll get into this. So again, this is all part of the process here. We're working through the building orientation and massing with Michael, and they are running through some envelope selections. But today we will be focusing on high performance MEP systems, how to fully electrify while providing a comfortable and functioning school. So that's what we'll be talking through today. And I don't know everyone's level of familiarity, but all questions are good questions, and feel free to jump in at any time if you have any questions or anything. Hopefully this is a discussion, and it's kind of an open forum here. It's kind of hoping what I can get out of this today. So as we kind of step through this, these are some of the selection criteria that we typically look at in K through 12 schools here. It's important to look at the big picture when we select a system. It's easy to focus on one thing, either first cost or life cycle cost or low EUI. But at the end of the day, we want to provide a fully functional, comfortable and low operating EUI school. And from what I understand, it is the town of Trumbull's goal to provide a net zero school to the town. Is that correct? Correct.
Yes, Ben.
Okay. And, actually Michael and I designed together one of the first zero energy schools in New England. So it can be done, and this team has done it before. So again, the selection criteria, keep these items in mind, and I'd be happy to discuss this criteria in regard to any of these options that we go over today, and we can say whether it meets or does not meet this criteria, or what we can do to change it. What's up, John?
A little context on your graph. Is closer to the bullseye better, or is further away from the center better?
Yeah, this is just a typical spider chart that we've seen before. So the further away out in the circle, the higher priority. So in this general example here, low EUI, low operating costs, high indoor air quality are all kind of the top three there. And as you get closer, it's less and less of a priority there. So so just keep these in mind, and we can absolutely go through any of these in more detail.
Thank you.
Yep. So when we look at the whole building and the energy of a building, we have to look at all the pieces of the pie. Lighting and plug loads are kind of a fixed number here. These percentages are kind of typical for these schools applications, but it can change based on what you have going on in your building. But in general, we see HVAC is around 45% of the energy, and the idea is to try to lower that piece of pie as much as we can, because that's what we have all the control of. And then kind of another step that's important and I'll go ahead and mention now, is just that kitchen design is always kind of a wild card, and it's important to get in front of your food service vendors, your kitchen staff, to try to understand their priorities, what they need and what they don't need, so that we can provide a fully functional kitchen at no cost to the operation that is a much lower energy consumer. So those conversations should happen eventually, and I'd be happy to start that whenever the time comes. But I think we're a little further away, and again, today we are going through the HVAC piece of pie. Okay, ready for the options. Here we go. So option one is air source heat pumps coupled with terminal fan coils. Option 2 is air source heat pumps. That is a hybrid system with the ground source geothermal field. So it's really very similar to option 1, except we take half or 80% or 70% of that load on the air source heat pump, and we take it from the ground rather than the air. But the terminal equipment at each of the classrooms is the same. So we'll get into each of these options a little bit more as we go along. The last 2 options are they're all geothermal options. So we're considering option 3 as geothermal chilled beams, and we will kind of walk through what that looks like. They're pretty whiz-bang technology here, and I think it might be a good selection here. And then the last one is ground source distributed heat pumps, which should be the best performing and lowest EUI. But again, there's pros and cons to each one of these, and we're going to go through them one at a time. Any questions here? All right. Okay, so here's the options 1 through 4. Starting with option 1, the cooling and the heating is provided by a 4-pipe machine that sits outside, either on a roof or in a yard, but in proximity to the mechanical room. And this provides all the heating and the cooling to the entire building. And 4-pipe systems 4 pipes will be routed around the entirety of the building to fan coil units, and there will be a fan coil unit per classroom. We pair up some of the classrooms or some of the office spaces if possible, but these come in very low sizes and very high sizes, and would be above ceiling. And they have a pumping system that's in the mechanical room, and each one, and the controls and valves and the ductwork and filters would all be above the ceiling. But this one's nice because all of the equipment is, the majority of the equipment is in the mechanical room, like the big equipment that requires maintenance. But again, the fan coils will also need a little maintenance as well. So option 2 here is pretty much the exact same thing, except we would cut in a ground source geothermal well field, and they would kind of share the load between the 4-pipe machine and the ground source. And we could really cut down and lower the energy by using the geothermal well field. But everything in the building would remain the same in that option as compared to option 1. Lastly, or I guess not lastly, options 3 and 4, again, are all geothermal. The terminal equipment is really what's the difference between the 2. For chilled beams, we would be using, again, a 4-pipe system that is that's pumped from the mechanical room, from the well field to chilled beam diffusers. So these chilled beams are like lay-in tiles, or they can go in exposed ceilings, either one. And they have 4-pipe connections. And this diffuser would provide the heating and the cooling directly at the ceiling space. We would pair this with an air handler that would be providing the air to each one of these. And the majority of the heating and the cooling is done at the chilled beams themselves. There's no compressors in the chilled beams. All the compressors would be in the 6-pipe water-to-water unit, which would be 6 pipes are the geothermal in and out, hot in and out, and cold in and out. And I have a good little diagram later on in the presentation that kind of shows this a little bit more in detail. Lastly, the geothermal heat pump. These are distributed water source heat pumps. So these come in sizes from a 0.5 ton to 15 tons. The catch with these is that they have the compressors and the refrigerant loop within each heat pump, and we like to put the heat pumps directly outside the classrooms. Typically, 2 classrooms are on 1 heat pump, and we would we would share the load between all the classrooms using the geothermal loop. In my opinion, option 4 is probably the most simple, but it does have the most distributed kind of maintenance items. This is a 2-pipe system. The only pipes in the building would be coming from the well field to each one of the heat pumps, and the heat pumps can be simultaneous. One can be heating and the next room over can be cooling. And in that situation, they're sharing the load. So you're even furthering your efficiency at that point. But again, this is a 2-pipe with single-in suction pumps, as compared to the 4-pipe system would have, hot water pumps and cold water pumps, and 2 separate closed loop systems when the geothermal option would only have 1. That's a lot there. I'm really kind of throwing everything out there, but again, if you have any questions, feel free to jump in. Yep.
So I'm just curious in terms of like the bigger spaces in the building, do you, with the options 3 and 4, because I'm kind of familiar with 1, clearly, how, like, is there more than one, like, how does the energy get to like the gym and the cafeteria? Because it's a bigger space. How many things are used to sort of heat or cool those areas? I don't know if that question makes sense.
No, that absolutely makes sense. The bigger spaces definitely can be a challenge from time to time. Option 4, they make 15-ton water source heat pumps. So they actually have a unit that looks exactly like the one you're looking at, except it's 4 of those wide, and it's a big unit, and it does the exact same duty. And we could put 2 or 3 of those in an auditorium or a gymnasium. I typically put a 15-ton heat pump that looks very similar to that in a gymnasium and an auditorium before, and they get the job done quite well. For the chilled beams, though, that is a little bit more in depth there. We would probably look to a small modular air handler for that kind of space. We have, with the chilled beam options, it's a 4-pipe system, so we have hot water and chilled water available. So we would probably look to use a small modular air handler to serve kind of the bigger spaces, utilizing the chilled and hot water in the building already at the air handling coils is probably how we would do that. Okay.
Thank you. Thank you.
Yep.
Yeah, I have a question.
This is Bob. I have a question.
Yep. Go for it, Bob.
I'm
Bob,
intrigued by option number 4. Have you put this system in the other schools that you've done net zero, and have you found it to be successful over, a central, say, chiller or air cooled solution with maybe bigger pumps?
Yeah, I'm a huge fan of option 4. That's probably my favorite system. The 3 schools that we've done, the 3 net zero schools that we've done with TSKP, were option 4 distributed geothermal heat pumps. We've had good success with it.
So as a follow-up, have you guys done any have you had any discussions with the end users, and have they been, happy, sad? What's their feedback been on those systems? Have they been happy, or, what's their take on it?
No, the majority of the issues they had were at startup, as always. But once we get through those initial jumps and kind of fine tuning over that first year, no news is good news, and I haven't heard a lot of news. So I think they're doing pretty well. And we've been tracking those schools, and they've been outperforming the model that we kind of predicted. But as far as the schools, I've been in them a lot of times. They're always nice and comfortable. Everyone had several people say they walk in and say it smells clean in there, which I've never had that compliment before. But maybe that's just their maintenance staff kicking butt. But I'll take the credit, I guess. But it does smell, and they have a good air quality. And it really is a simple system because there's really one set of pumps that's just moving water to and from heat pumps around the building. And if the heat pumps, if the heat pumps are off, it's off, and you're not using any of that energy. And these heat pumps like to run at part load, and they have single stage and double stage that can take large portions of air and cool them, and even dehumidify the bigger units.
Yeah,
Let me go ahead, Brandon.
I was going to say, if I could jump in. So three of the four projects we did with CMTA were in Manchester, and they have a continuing building committee, so they've continued to meet on all other projects, and we still attend those meetings for a variety of reasons. So like the first school we did, Buckley, has been done for 3 years now. And so we still hear reporting out to the committee on how the building is performing. And, occasionally there's a punch list item that'll come up or something. And I can tell you, they haven't had any real issues on the HVAC system on the first two. The third, it's been about a year, and they're still tweaking. There's a little temperature issue in 2 classrooms they're trying to figure out, kind of that normal stuff. But in general, they've been pretty happy with the systems, and they haven't reported out any concerns or any, there hasn't been any second guessing on their initial decision. I think they're quite happy with the route they've taken.
Thank you.
Yeah, I have a question about these systems. Do you find that the equipment is readily available, or these long lead items, or how do you handle that?
So the only long lead items that you're seeing on screen right now are those air source machines. The heat pumps are
which ones? Which ones are
the air source machines? The big box fan looking things in option 1 and 2 for the heating and cooling source. Those are specialized systems that are that take a little bit longer and a little more expensive to get. But as far as like the distributed heat pumps, everything in those units they're no different than what you have in your house. A small little compressor with a little refrigerant loop, just a single fan. So if anything, it's just off-the-shelf compressors, and then fan coils are pretty much a commodity at this point. So there's plenty of those, and chilled beams. The lead times for those are not bad, especially at a project of this size. They'll take care of us. And as far as the geo, it's just the ground, so there's not a whole lot there. But yeah. In terms of replacement, is that what you're asking about, James?
No, I mean in terms of how far in advance do we have to decide if it's a long lead item? Like, are you talking 6 months?
Oh, yeah,
months?
no.
It
Should be good.
Well, what do you mean by long lead then? How long are you talking about?
You're looking at like I don't know, the air source heat pumps are maybe 6 months.
Yeah, okay.
Months to 8 months, depending on the manufacturer. It widely ranges with the manufacturer, and we're in the midst of a large refrigerant change at the moment too. So everybody's changing their 410A systems to 454B or 32. So that can affect lead times as well.
Can I ask what type of maintenance for option 3 and 4? I'm familiar with the maintenance for options 1, but what type of yearly or quarterly maintenance would we be getting into with the geothermal?
Yeah, so the geothermal, in terms of maintenance on option 3, there's, instead of distributed heat pumps, there's a single large, here, let's just go to that slide. What do we do? Let's just do that. We'll hit that while we're here. We're going to go through all the pros and cons, but is that what I wanted here? Yeah, so here's the chilled beam design here. And I was going to mention that each one of these items what you were seeing on that matrix is just for the heating and the cooling. Each option has an additional DOAS that provides dedicated outside ventilation air to all of the spaces. And the air handling, the DOAS would be similar maintenance to any air handling unit that you've ever seen. Just fans and changing the filters and really just making sure the coils are not fouled up or anything like that. And then for this option, this is a 6-pipe water-to-water heat pump, which you're seeing on screen. And that is what would need the periodic maintenance. You would have 3 closed loop systems. You'd have a geothermal closed loop, you'd have a hot water closed loop, and you'd have a chilled water closed loop that you would have to do quarterly or biannually chemical treatment and, just your typical closed loop hydronic system maintenance. And then the chilled beam itself, there's not a lot of maintenance required on those. Sometimes they have filters in them, sometimes they don't. And you would just, they have little faces on them that open and you could get at them there. But the control valves and the condensate would be above ceiling, which is really the only thing that you'd have there. So that's about it. And then on the geothermal water source heat pump, it's very similar, except it's only 1 closed loop periodic chemical treatment maintenance, and then just making sure that all the compressors at the distributed heat pumps are good, and the filters are good, and again the coils aren't fouled up or anything like that, and again just the DOAS.
Okay.
All right, let's jump back here. Let's get into, yep, what's up, John?
Just as a generic, order of magnitude for, hypothetical 100,000 square feet of space, as you mentioned, the big box spaces will need their own system. But as far as classrooms, offices, and the like, what would you think is a reasonable quantity of these distributed heat pumps in say a theoretical 100,000 square foot building?
Let me do. Give me 1 second. You said 140,000?
Well, I was just thinking, just modularly 100,000.
100,000. I'm sorry, I have a number here. So we had 25 heat pumps, around 25 heat pumps at the 65,000 square foot. So that would be around, you're looking at like 35 to 40 of these, maybe less. Again, you can, and then in the fan coil option, you're looking at, double that number for the fan coils, because you have 1 per space. These we would split. Here's a typical layout of a classroom here, where we have this is a major con. This is one of the big cons that I was going to get to here, is that for the water source heat pump option, we have to play a little find and seek game, hide and seek game, where we try to locate 6-foot by 4-foot closets to install these units right outside the classroom. And then it just dumps the air into the classroom, and we have a separate VAV from the DOAS, again kind of shown there in the corners of the rooms. But really that closet is the crux. And again, if you were to do this with fan coils, you would have 1 of these per classrooms.
No closet necessary, but a device per room.
Correct. Correct.
Thank you.
Well, you could have 1 unit that feeds multiple areas. I mean, you could do like a whole wing or like a whole hallway with one rooftop unit or 1 fan coil unit, correct? You don't have to have a unit per space.
If we were to do distributed fan coils with a four pipe system, we would look, I mean, we could do, share the classrooms with a fan coil, or one fan coil for two classrooms, but then you don't have as good temperature control, and then it's a bigger cabinet, and then you have to fit that cabinet above ceiling. So it could be doable, and that would be something that we would talk with you guys of what you're comfortable with, and whether you'd want those in the space or in the corridor, or how many you're willing to team up. But in general, you want to at least team up the exposures, so you're kind of driven with that. But none of these options really consider a central air handling unit.
Yeah, just real quick. It is possible to gang spaces together, but you'll need to gang them by, like Ben said, by exposure. Southern facing spaces need to be grouped together, and by use type, because once they're on the same unit, they can either heat or they can cool. They cannot heat and cool simultaneously. So you need to cluster them accordingly if you wanted to consolidate.
Got it.
Yeah, so we'll just run through some of these pros and cons for each one of these options. Again, air source heat pump, probably the worst performing. It would be kind of a stretch to try to get to zero with this one, but it can be done with canopies if that's what you guys are comfortable with. Has a lower first cost, but we'll walk through the life cycle over the course of this presentation. And then kind of the big units is we don't have that problem with the distributed units trying to fit them in classrooms. All the compressors are in one location, so you're not running from one wing to another wing to look at that. But again, it's higher life cycle costs, more system piping, and kind of the other things that we mentioned. And in kind of the same vein, it's very, very similar here, except it's just slightly lower energy consumption. And then there would be a little bit more equipment and controls needed to integrate the geothermal with the air source loop. But very similar pros and cons here. And then we have the chilled beams. It has a lower energy consumption compared to those first two options. We just have an air handling unit that would distribute the air to each one of these little ceiling cassette devices that provide the heating and cooling. So there's really nothing above ceiling other than the actual terminal unit that's visible in space. And you have very few distributing compressors and filters, as we said. It's a little higher first cost from the well field itself. It has the four pipes. Another big option with the chilled beams or con with the chilled beams is that they have really specific dew point requirements, and it'd be very difficult to get, let's say, like operable windows in a good option like this, just because they are kind of prone to condensation. But again, this is monitored, and we would design it so that it wouldn't do that. But it is a well-known con of this option in this industry. And then again, there's just a little bit of controls above the ceiling with the valves at the terminal units themselves. And lastly, the ground source heat pump. It's the lowest energy, lowest operating, least PV, probably comparable to the chilled beam option, very similar in first cost. Probably a little bit more expensive because of the need of all those units and the install of those units. And again, the cons are kind of what we said. You have to run from one wing to another and check everything, and integrate these distributed units into that floor plan from the get-go. And that's kind of the big effort right at the front, is trying to find all these guys' homes in the very beginning. But they're distributed, but they're also very accessible. They're all right there in front of you. It's not like they're above ceiling or anything. You're not going to be up on a ladder, so it's all right there. So that's, and I have a picture of one coming up. So then here's kind of an overall of the suggestions and benefits of what we have here. Again, the air source is probably the lowest first cost. We kind of have in my mind, a fair, good, better, best here in my mind. And the maintaining and maintainability and simplicity is there for that option 4. There's a lot of things you can do in the design for the hybrid and the air source loop to make it a little bit more energy performing. But again, just the nature of air source versus water source, just apples and oranges in terms of the efficiency. Okay. Do we know kind of the term EUI? Are we familiar with that term?
Assume not.
Yeah, Ben, just give them a quick explanation of it again.
Okay. Yeah, so EUI is a metric that we use to determine how well a building is performing. It is all of the energy consumed by the building over an entire year divided by the square footage. That's the energy from the plugs, the lighting, the IT, kitchen, everything. If you have gas, that energy also counts into your EUI. And you take all that energy, add it up over an entire year, and you divide it by your square footage, and allows us to compare buildings of similar type, but of very different sizes to on the same playing field, so that you can kind of eliminate the size factor and how much you're using, and compare it to how well you're distributing that energy over the entire building. So we have a EUI chart here on the on screen, and these are kind of ranges that you would expect these 4 options to be in. Geothermal heat pumps, the 20 is probably a little bit of a high range. We've seen them perform anywhere from 17 to 22 EUI. At the geothermal chilled beams, you could expect a slightly higher. Again, you could probably imagine around 22 to 25-ish. The air source heat pump and hybrid geo, you could expect that one around 30 to 35-ish. And then following that would be the air to water full air source heat pump. And typically for zero energy schools, the big number is 25 EUI is what we want to try to be at to fit all the PV on the roof. That's kind of been our magic number. But the lower that you get that EUI, the less PV you have to buy, the lower, the less, upfront cost you have to get, and the more incentives you get. So, that's kind of how these break out and what their baseline EUI or what their EUI targets kind of would be. But again, we would build a full energy model of your new school, and we would model it over the course of a year and try to target that low 20, and kind of an exercise that we do to try to lower that EUI to a point where we can get it all on the roof. And with those numbers, we should have no issue with that. All righty, we already looked at this slide, but we're going to look at it again. I love this little graphic here. Again, this is the 6-pipe unit. So this would be in the mechanical room here. Can you see my mouse? No.
Yeah, Ben, which option is this, Ben?
This is option 3.
Okay.
I have a little bit more detailed analysis and system review for options 3 and 4 coming up, and then we'll end with the life cycle cost analysis, kind of high level of what we could expect. But I wanted to highlight kind of these lower EUI options, knowing the goals of this project. So we have a 6-pipe unit here. Like I said, this would be that live in the mechanical room. 6 pipes, It's got all the compressors in it, modular. You could probably have 5 or 6 of these things stacked up in the walls. It wouldn't be this small, be a little bit bigger, but this would provide all the heating and the cooling for the entire building. And you'd have 2 of these little pumps, or you'd have a chilled water pump and a hot water pump, you know, distributing this water to the DOAS and the chilled beams. And then, you know, of course, the air comes from the air handling unit into the top of the chilled beams and either gets heated or cooled to set point. Here's a typical chilled beam classroom layout. You have 5 to 6 of these in each one of these rooms. And you have you can see the control valves and kind of the layout in this right-hand corner here. But again, they're nice and clean. You know, they look like a diffuser, they smell like a diffuser, but they're not a diffuser. They have it's its own terminal unit. Again, this air is coming from a DOAS, so this is raw outside air that's been conditioned, and then it's provided to each of those terminal units. And then here's a little closer up of what that chill beam looks like. You can see those coils inside of it. You know, the ductwork connects to the top of that. It doesn't have a fan in it. There's not a fan in it. All the static is taken care of at the air handler itself. And then again, here's the modular chiller heaters that we've been over. And you know, this is kind of the heartbeat of the entire system here. This is doing all the work. Okay. Then we have our distributed ground source heat pump. You know, the 2-pipe system, just going to the distributed heat pumps. Again, for these larger spaces, they do make geothermal heat pumps that can cover entire large meeting spaces and assembly spaces. I guess one thing I'd mention is that there is also a water-to-water heat pump associated with this design. You know, this little box here provides, it takes the geothermal water and it either provides hot or chilled water to a dual temp coil in the DOAS itself. So you're eliminating a coil, and this little unit, you know, is interlocked with just the set point and the leaving air temperature of the DOAS itself. They do make this packaged where you can take this box and put it in this box and just bring water to it. So that's something we might look at. But there is, you know, some sort of pressurized cooling and heating that needs to be done so that the DOAS can provide conditioned air. Again, a little closet slide. I typically take little squares and litter them all over the floor plan, and we try to find homes for them. And you know, you also can put more than one of these in a room. You know, I've seen them do, you know, a mechanical room per wing, and they'll put a mechanical room kind of central to the wing, put 5 or 6 of these heat pumps in there, and then route them to those spaces. So it doesn't have to be just one in each closet. We can buddy them up. Typically, we use 4-ton heat pumps per 2 classrooms. So 2 tons per classroom, 4 tons total.
Do they generate much noise, Ken? I'm just wondering on the noise level with these pumps.
Yeah, that's a good question. They make these so specialized now that they have, you know, highly acoustically rated cabinets. They have sound blankets for the compressors themselves. And we always spec the first 10 feet of return and supply ductwork to be internally lined. It is a valid concern, and we're always, you know, going back and forth with the acoustic engineer to make sure everything is taken care of. But, you know, I think they're really quiet. I really do. I think they're quiet. I haven't had anyone, tell me that they were loud. But they make a lot of accessories that we would explore to decrease that sound.
Okay.
Ben, what about on a day like today with dehumidification, with this crazy humidity? Would there be an issue with condensation, or would this system be able to satisfy these spaces?
Oh yeah. They can do that all day long. Again, they're not, these units themselves are really not seeing any of that humidity. They're just recircling in the space. That's all they're doing. And if they, the larger spaces, we do spec a 2-stage operation and a dehumidification sequence on the larger units. These units can dehumidify, but we haven't seen the really need to do any of that. The majority of the dehumidification is done at the dough as itself. That's taking that outside air, conditioning it. But those Inflipy wheels that we would put inside of it, the energy recovery wheels, they knock out a lot of that right off the front, and it's really great for reclaiming that energy on a day like today. So, yeah. So this is, again, there's each closet would have a drain. You have to route the condensate from each one of these units to a drain. The only condensate issues I've had are drains being clogged. So it wasn't the heat pumps, but yeah, this is kind of a picture. What's up, Fran? How are you?
Good, thanks. How are you?
Good.
Just a quick question. These ones, you need a closet for each classroom?
It's one closet every 2 classrooms.
So that's a lot of space dedicated to these closets.
Correct. That's the major con there, yeah. And they do have horizontal units, but then you're looking at a much bigger ceiling plenum that would be required, and then you're doing all the same maintenance that you do here, but you'll be doing it up above the ceiling. I have done that before. I have a little more grief from the maintenance staff on those, but it can be done. And one of these we had a really whiz bang, little half height crawl space, and we stuck maybe 20 of these heat pumps horizontal style in this little crawl space and hid them all. So there's unique ways that we can come around and find homes for these, and as long as they're strategically planned for from the get-go, it usually ends up working itself out. Okay. All right, the last 2 slides here. So this is a typical life cycle cost analysis. So this is a fairly high level based on the quoted budget. I think it was in the proposal around these numbers here. So these are kind of all things being equal. If you take all 4 of these options and you drop them in a bucket, here's how they would perform over time. The plus or minus first costs, but the slopes and the kind of the replacement costs are reflected in this. And kind of what you're looking at here is over a 30-year period, how much the system would cost. So the slope of the line is made up of the maintenance and the energy costs and the replacement costs that are associated with each of these systems. So the air source heat pump kind of has the highest energy consumption, so that would have a little bit higher of a slope, and then those big jumps in those years are the replacements. You could expect that the air source heat pump and hybrid options, you would need to replace those those central units in year 15 or so. And the chilled beams, you'd have to replace the 6-pipe water-to-water unit at some point, the compressors associated with that. And then over time, kind of the overall goal here is, first cost is what it is, but over the course of, 30 years, it works itself out to, the geothermal option will be the lowest life cycle over the course of those 30 years. And another big component to that is you don't have to replace a well field. A well field is a 50-year installation. You could, 30 years from now, you could build a new school and, decide, we hate the school, let's build a new one. You could reconnect your school to that same geothermal loop, and it wouldn't have any effect on it. So that those jumps there, you're going to have way less of a maintenance or a replacement cost associated with the geothermal systems. On top of this, you're not really seeing with PV, these first costs kind of work out too, where you pay more for your PV and then you have to replace your PV, and you have more of it. So that kind of comes into it. But kind of all I'm trying to get to is, first cost isn't everything. And over the course of time, everything shakes out to be even, where the ground source would probably be the most economical option. And then to layer on top of that, we would absolutely be going after local incentives, energized CT. We would be going after the full occupancy, post-occupancy incentive. And you can see those incentives hit on kind of in that first couple of years. I'm seeing an error in this now, but there's a decrease in the incentives at the very beginning, and then over the course of that time, that shakes out those numbers to be even more impressive over time. And we would absolutely be going after these incentives, which is a cost per ton. So it's $1 per ton of geothermal installed, as well as a dollar, or I think it's like $2.50 per square foot, or $1.50 per square foot, if you meet your EOI target. Yes.
Yeah, so I just wanted to verify the start of your graph here. That includes the cost of drilling for the wells?
Correct.
And any idea, based upon what's already been discussed with the types of school, size of school we're looking at, how many wells you would need to drill for this?
I'm going to jump in on this one. I would say it's a lot of it depends on what the soils are like, which we will start to confirm with the geotechnical investigation the end of this month. But we're looking probably in the range of 100 to 120 wells, about 500 feet deep. Those would be closed pipe systems, so we're not depositing any water into the aquifer. We're just looping our building water or our well field water through the earth to absorb its heat or reject our heat.
Yeah, I would agree. I think it'd probably be around that number, probably 85 to 100-ish. Maybe a little bit more, depending on the soil. The soil has a big component to it. You can get great soil and half your well field sometimes. Depends on what's there. And but you're right to ask that question, because the majority of that first cost and that premium of that first cost is tied up in that well field. We've seen anywhere from $30,000 to $40,000 per well. So it gets up there.
And then do the spoils have to get transported off-site and dumped somewhere? How does that work?
So what we would do what's called a test well. and a drill rig would come in, and we would hopefully at that time have an idea of where this well field would be located. And we would do one 500-foot well, and they do a 48-hour temperature test in which they're running water through this loop for 48 hours and measuring how much the ground is absorbing and not absorbing. All the while they're measuring the geology as they move down to kind of help the future drillers understand what kind of rig they need to use. But it's not transported off site. We would have a capped well there throughout the design process, and later on we would base the full well field around the test well and eventually use that as part of the design.
I think the question about the drilling spoils.
Yeah. There would, unless there's contamination involved, it would really be up to the site contractor on what he wants to do with that material. If he can reuse it for borrowed fill, or he will, or if it's excess material, and again, if it's not contaminated, he'll figure out where he wants to put it.
Great, thank you.
Any questions for Ben? I know there was a lot of material here.
Yeah, I have another question.
Go ahead, Jim.
When you're doing this drilling, Trumbull is known to have a lot of rock. If you hit a lot of ledge, is that drilling cost going to increase, I assume?
No, rock is not a problem. It's water that's a problem. We run into a lot of water, and when you're drilling, the water comes out, and then you have to dewater. That's where it becomes more of an issue. But rock can be a good thing.
Okay, good. We got plenty of it.
Hey, Ben, could you go back to that table showing options 1 through 4 for a second?
The photos or the pros and cons?
No. We're going to talk about this in a second. The first opening slide where you had the 4 options. Yeah, those. So I guess my question is, I do not see VRF as one of the options. Could you just explain to us why that's not on this table?
Yeah. So we, in our experience, VRF is a perfectly fine system. But at the end of the day, it's an air source heat pump is what it is. And so it's a very similar performance. It's a little bit better than an air source heat pump design. But with the refrigerant changes and the level of monitoring and the highly skilled trained installations, I tend to stray away from the VRF, but it is a very, very common option. And it is something that we could consider if that's what we would like. But I've heard a couple horror stories, but there's horror stories for all of them. But it really comes down to highly trained installations, and then you're locked into a service contract with whoever's doing that for the lifetime of the building, because there's all this refrigerant everywhere. And this refrigerant now needs to be monitored at all times because of the new codes. It's been done at a lot of high performance schools. There's definitely zero energy schools that have VRF, but just the level of oil trapping and pitching of the refrigerant pipes, and really that service contract aspect is a big key component there.
Mm-hmm. So you're not recommending it for this school or for this project at this time?
I mean, we could consider it. I mean, there's pros and cons with everything. So, I'm not locked into a no there.
Okay. Now the other table with the one with the dollar signs, could you go to that one for a second? So, these relative dollar signs don't mean a lot to us. I think what I would like to ask the design team and the construction management team is to put some relative costs to each of these columns and then report back to us in a couple of weeks so that we can get a sense of what the comparative of costs would be on a square foot basis would probably be fine. We're just trying to understand, you know, we love best, but we want to make sure that best doesn't cost 3 times as much as fair, good, fair. So, you know, we need a little bit of information and comparative numbers, real numbers. And if you want to use the square footage of the program and do the math, that would be very helpful also. I think it would be good for the committee in the town to see those numbers and then be able to make a decision on which way to go. I've done schools for all of these, including VRF, so I know I'm very familiar with the pros and cons for each one of these. But costs have changed a lot in the last few years, and we'd like to see what they cost on a comparative basis. And what's very important in that analysis is that we also include the premium of the square footage that's got to be built in the building. You know, for the units that sit on the floor. That's very, very important, and it does add up and adds up pretty quickly. But that's an important consideration, as well as the well field cost. So if we can get those numbers on a table like this at the very bottom, I think it would be very helpful for everybody. So, Greg from Bismarck, can you help with that process?
Yeah, of course. I'll take actually, I'm going to just take a picture of this, and we're going to put in the numbers per square foot for each one.
Yeah, Ben can also send that to you, Greg, so that you have it.
Yeah, we've done that plenty of times for this exact same application. You know, everything is kind of on that per square foot basis, and would be kind of based on an estimated EUI based on the system type. But yeah, absolutely.
Fantastic. Okay. Anybody else have any other questions for?
We got two. We got two here.
Okay.
Ben, thanks. It's Ann Sather. I just when you said with the geothermal field and the end of life is about 50 years. Is that what did I hear that right?
Yeah, I mean,
after about 50 years, you need to 50, replace it?
No, it's 50 plus. It's 50 plus.
Okay.
It's really
sorry.
I
don't intend to be around in 50 years, but there's a good possibility that my kids will be and their kids or whatever. So, and there's 9 schools in the district. So like, you know, it's quite possible that building will be 50 years old easily. So just want to make sure that is something that it will keep functioning, heating, and it won't be an extraordinary, that's my concern, is that 50 years from now, it'll just stop working and they'll have to figure out something brand new. And I don't know if I don't know. Anyway, just, okay. 50 plus is good to hear. Okay. Thank you.
Yeah. Yep. John?
Yeah. Given that we're in New England and we have a thing called winter, my classic question on these system selection discussions is, how are we freeze-proofing the building?
Well, with the geothermal systems, everything's underground, and everything is below the frost line. And the only thing that would really be freeze protected would be the DOAS. But if we were able to put that inside, which probably won't do, but
I wasn't clear. How do we freeze-proof the building? How do we keep the building itself from freezing? I've got plumbing systems. I've got a sprinkler system in the building. How do I keep the building above freezing in an ice storm in February? If we lose our power, how are we going to freeze-proof the building?
Okay. Yeah. So, you know, a shelter-in-place situation, you know, we would have to kind of talk through. Is that what would happen here if the power went out, or, you know, we would.
I'm not looking for occupancy. I'm looking for building survivability. And the typical answer with a heat pump system is, well, you run it off the generator. So as part of the life cycle cost analysis in this, difference in systems costs if we're going to put a square foot cost to each of these four options. If a normal fossil fueled heating system would require a generator for all the other generator necessities, that's $100,000. How expensive is the generator that is needed to run a building that's all electric in order to freeze proof
so
it?
we would look to probably run the dough. We would run the dough at heat, and we would keep the building above that freezing temperature with just the dough and then we would only be running the dough itself and the central system. And if we want really to inflate that generator, we can put certain heat pumps on the generator. But we would look to to put the DOAS on the generator as well as the geothermal pumps and really turn up the heat on the DOAS, and that is provided to all of the schools and would limp along as we get through and make sure that we won't freeze that building. And the envelopes now that we're designing to in these buildings are top of the line, so it would take days and super cold to really make any effect anyways, if in my opinion. But definitely a great question. And in the past we've done on-site generators. We've also done emergency transfer switches where a roll-up generator can come on in addition to the generator itself, if there is one. And we've also swapped out generators for battery systems. We've done that before on some other high performance facilities. So that's also something we could look into.
Jack, you bring up a good point and a good question, and maybe this is for Taisu Kim, who are probably the most familiar with the ed spec. What is what is in the ed spec regarding emergency power for this building? This is not a place where people go in case of a storm or anything like this, is it?
No, it's not. That's not part of the ed spec. So,
okay.
I mean, essentially, we'd be looking to give occupant comfort. If loss of power, you just have to keep occupant comfort until you can get the kids and staff home, and then we would go into this emergency protocol that Ben's saying, where we would run the systems at a minimum, probably by zone throughout the building, monitoring the overall temperatures. But Ben is saying is correct with the high performance envelopes that we look to for net zero schools. We do an overall building air infiltration test at the end of the project. We find that these buildings hold their residual heat much longer than even a regular Connecticut high performance school, which is typically reliant on far more air changes to maintain its air quality.
Okay, so the emergency generator would be sized in essence to protect the building itself. So in other words,
protect the building itself. Often, the central data closet's going to be on that. You'll probably want your food service refrigerator and freezer. We would work with Trumbull Public School facilities to understand better what their expectations are for emergency power needs.
Okay, and I'd assume that even though this is an all electric building, we would be burning diesel fuel to run a generator, I assume.
We can in the instance of, say, the Manchester schools, all we really did was leave them the transfer switch inside the building and an external hookup, because as a district they invested in a portable unit that they could deploy around the district as needed.
Okay, thank you. All right.
I should say just real quick, based on comfort level with some of these systems, I mean, certainly with any of these, we can refer you to clients that have road tested these very systems for some time, and let them speak for themselves as to how they feel, what the ramp bus training was for it and what lessons learned they have from it. Okay.
Yeah, I mean the concern obviously is operating cost and maintenance, right? That's an ongoing killer for districts, especially when we're talking about a building that's going to be 30, 40, 50 years from now. So that maintenance and that the reliability really has an impact on the school budgets and the personnel that have to maintain the building. So that's an important factor in any selection. Are there any other questions for Ben? No, thank you very much, Ben. Appreciate that presentation.
Thank you, guys. I appreciate it. Thanks.
All right. Taisu guys, do you have anything for us tonight, design wise?
No,
Or you let Ben carry the flag tonight.
That's right. He did all the lifting tonight.
Okay. All right. So
Let mine work there, Ben.
Thank you. Let's move on to our friend Jack, Arcadis. Do you have an update for us, Jack? What's going on?
Yeah. Good evening. As we mentioned at the last meeting, we're in midst of working through our contract. One of the discussion points on that contract was overall schedule, because the information that was shared in the RFPs for architect and for CM were a bit different than what was shared in our RFP. So we've done an exercise where we kind of normalized it. We've taken the actual start date of design. We've taken the durations that were in our contract, discussed it with both TSKP and Bismarck, and have come up with kind of a yep, this works version of the schedule. Right now, I want to do a little bit more refinement to that before we start showing it as an example. But the durations provide enough time to appropriately construct the building, as well as do the abatement and demo. Right now, the target dates of when we would break ground on different phases of work leaves a little bit of a gap between when we would occupy the new building and when we can realistically get into the old building and start taking it apart. So we want to, I'd prefer to close that gap a little bit, but I don't know that we can cut 6 months out of the schedule in order to make that overlay. So we're still working on that, but basically, from the context of the schedule that Arcadis has been working from, it all works. Everything is, no exceedance to the project duration that was provided in the sample given to us. What that is leading towards is an occupancy date. I hate the way this thing prints out. Student occupancy date of well, we would move in for the start of the 28-29 school year. The substantial completion date at the moment looks as though we would be done with major construction in early March of 28, but nobody's going to want to move into a new building on April 1st. It would just be too disruptive to the school year. So we do have that bit of a deadband there between there and June, when the school year is over and we can actually move into the old building and start our abatement and demo process. So that's kind of the linchpin of everything, is waiting for the school year to complete before we can attack that. Right now, abatement, demo, site restoration all fits within the stated number of months, but that puts us outside the planting season, so that there's likely that some site work would need to come back in the spring of 29 in order to do final planting and seeding and things like that. We have options. We can look at sod on the fields instead of seeding the fields. There is, of course, a period of time where we'd like to let it get settled and get rooted without playing on it right away. So a lot of variables that we have plenty of time to work out as far as how we're going to spec that area of the project. But right now, as Michael has been cautioning us, the state traffic permit is a critical path activity. We were happy to hear that we're not subject to zoning, but we want to go through the other town agencies, wetlands, most notably, and those are all predecessors to our getting our approval to go to bid from the state. Right now, again, as I said, this is laid out with durations that have been vetted by TSKP as being reasonable within their anticipated design schedule. And again, the construction component of it was verified with Bismarck that it'll all work. We're just trying to tighten it up a little bit. So that was probably and again, since that ties into the discussions, the last couple of questions regarding our contract, we just wanted to do a kind of proof of concept, make sure that everything would fit and not expose the town to any additional costs for extended services and whatnot. So far, so good. We do have a meeting scheduled, or we're looking to schedule a meeting, the design conference with our funding partners up at the state. It's kind of a refresh of a process they used to call the prep meeting. They're adopting this new format. It's kind of been around in the statutes, but they were doing things a little differently. Then they stopped doing it at all. But as of July 1st, they came out with a new guidance memo that articulates how this is going to fly, which is a very good thing for the project. I think it's a good process. Right now, we're just wrangling the necessary staff and availabilities to be able to pin down the date, but it will happen before the end of July, which would be beneficial to all of the players. So right now, that's our current activity is trying to nail down that meeting date, and we anticipate the progress of design schematics to be on schedule in end of summer. Correct, Michael?
That's correct.
Yeah.
Hey, Jack, on that guidance memo, I'm wondering if you could issue that to the folks that are listed as participants in that meeting.
I think some have already seen it, but yes, absolutely, we'll get it out. In fact, I can send it to you to distribute as an FYI item to the entire committee. It really becomes the script to a meeting that they anticipate will be 2 hours long. But I think there's a lot of good content in there. So I'll get that memo out to you tonight.
That'd be great. Is it much different than the old style prep meeting?
It's a brand new format of the way that they're listing the information. I think we're going to hit the same basic high points that we used to do. But again, this ties closely into the new regulations that they've proposed, which we still don't have an active date for. Comments were open until someday in May, and I know comments were submitted to tweak what they're asking for, ask for some clarification. But this is kind of the first step on that path of abiding by the upcoming regulations, and it's definitely a good step.
Okay, who's our reviewer on the job?
Andrea.
Andrea, okay.
Yeah.
Thank you. Any other questions for Jack from the committee? You guys okay? Jack, thank you very much for the update. And if there's any questions regarding contract stuff, just please work with Jim and get those resolved. All right. Let's talk about the CM's update. Greg,
if I could, Joe, I see Kevin is still with us. I know we had talked about the next consultant that needs to be added to our team is the commissioning agent. Kevin, do you have a trajectory as to when you think you want to get that RFP posted? I know we provided some comments. I'd be happy to work alongside of you to make sure we're capturing the scope the best we can.
Yeah, so I'm going to start working on it probably sometime next week. I have your version, my version, and then I'll do a couple of reviews to send to you and Greg and see what you think. You hit us at the wrong time of the year. It's end of fiscal year. We have 1,000 POs to close, reopen, 500 blanket POs, selling about 40 items down surplus. So you hit us at the wrong time to put that out. So we're going to have to delay that with, I had a renovation in my office. So just hit the triple play there. So we'll get the commissioning draft out for everybody to look at, even Jim Nugent to look at, make sure everything on there. So it's probably sometime next week. We should have at least draft one for people to review, and then we'll keep going back and forth until we get it done.
Yeah, happy to work with you and work through the
Yeah,
the
and I
different
think
examples.
Jack, just to let everybody know, we're kicking off that meeting, I think, next week, right?
That's right. We have the finance meeting scheduled for next Wednesday morning.
Yeah, so to
So
let everybody know on that is Jack and his crew, finance, Kevin Dion, Board of Ed. We're gonna set up a file cabinet system, central location for all bids. And that's the reason being for that. It's not only this school's because we had issues with audit, and we're still finishing the audit now for Trumbull High School and find contracts and all the original bids, because all Trumbull bids aren't scanned, they're original. So we keep them with the state for 7 years, and I have some over 15 years up in the office. So we're gonna keep these more direct line with Jack and his service, and the girl that works for him is great. We're gonna start that off on the right foot on this one with finance, Maria, Lisa, AP, Kevin Dion, myself. There's a whole bunch of us. So that should really get this off on the right foot. We're excited about it next week. That's all I have.
I have one just question about the materials tonight. I don't know if those were circulated. Is it possible to get that? I'd like to absorb the information we received tonight a little bit more or a little bit longer time frame. Is it possible to get that emailed or accessed somehow?
Yeah, we can send that. Joe and Barbara, maybe we'll send it to both of you. Jack and Greg will copy you as well, but we'll send the PowerPoint out. Okay.
Great, thank you.
All right. Jack, anything else for tonight?
No, thank you, Joe.
You're good. Fantastic. Thank you. Let's switch over to Bismarck. Greg, do you want to give us a report what's going on? I already asked you for some services. How's your contract going?
Can't hear you, Greg.
Minor little correction.
Greg, we can't hear you.
Greg, we can't
at
hear
all. You got yourself unplugged there.
You know, I'm gonna have to find a safer place without kids. So, no. Jokes aside, I have meetings scheduled Thursday with Jim, and we're gonna probably iron out some minor details with contracts. So that'll be resolved. Then later on this week, we're also going to be having some drone footage ran the site. Michael gave us I think it was the preliminary site from Langdon, and we're going to take that and just kind of overlay it, see logistics for us, and we're willing to share that when we get that resolved. And then the last one we have, I just want to know, Mike, when is your next design meeting with Hillcrest? I just didn't know if we could tag along.
I don't know if we really have one scheduled with the faculty or educators
Okay.
right now, but we'll keep you and Jack in the loop. Okay.
Okay. Sounds great. That's it at this time.
Okay. Anybody have questions for Greg? No? Okay. Let's move on to the next topic, and that is the date of the next meeting. Barbara, if I'm not mistaken, it's July 22nd, and that will also be virtual, right?
Yes.
So, okay, great. And if anybody has trouble going to that meeting, please just let me know. I want to make sure that we do have a quorum and that we can have that meeting. So just let me know ahead of time if you don't mind. All right. Are there any actions for approval? I don't think there are tonight. You know, tonight we've just gotten a lot of information thrown our way, and we need some time to absorb it and to come back perhaps the next time, ask a few more questions. Greg, I don't know if you guys can put some of those big sort of block numbers together for us in 2 weeks. I don't know if you can do that with the team, or if you need
Yeah,
more time.
I think we can definitely get something together, you know, big numbers, you know, high level stuff. So
Yeah, I mean, it's comparative, right? We understand that
Correct.
the numbers can, the actual number is going to be different than the comparative number, but at least what we can see is, what the magnitude of cost changes are.
Correct. And right now, we have a couple projects, both I think in 3 of the different options. So it's really going to be in real time too, which is good.
Fantastic. All right.
Yeah, getting you to weigh in on lead times too, Greg, based on what you're seeing in the industry.
Yeah,
So
I
cool.
you know what? I'm not gonna lie. For the engineer, you were nailing the dates. I had 6 months for a couple. You were right there. I'd give you credit.
All right. So far so good. But Greg, we'd be more than happy to work with you next week and help validate your numbers. So
Of
just reach
course.
out and we can
Yeah.
schedule
Yeah, I'll
something.
definitely talk to you before sending them over. We'll look at them together.
Yeah,
And
please.
and
I've put that together a couple times too, and we can absolutely compare numbers and get that together in a couple weeks. That's not a problem.
and then ultimately, it's not like we need a decision on a system in the next couple of weeks, but at the end of SD, I could imagine if we've narrowed it down to say maybe 2 options, then we can run, a real estimate on the actual drawings and a real narrative of what those systems are, and then do a real life cycle cost. And then, you can make your final selection based on more hard data rather than the rules of thumb, which are kind of what we're talking about right now.
Yeah, we just don't want to slow down the process, Randall, by, holding
Understood.
up a decision. And, you're in the back doing your drawings and getting stuff together and dealing with square footage. So we want to make sure that we're not slowing you guys down at all.
Yep.
The one thing I think might be very helpful for John, is to be able to contact, some of the folks that run those schools that you guys are talking about. I think if you could send us phone numbers of people he could call. John, you don't mind doing that for the committee? John Morello?
Absolutely.
Yeah, I mean, you can talk shop with those guys and find out, you know, how some of those systems are operating because, obviously these are new systems.
Yep.
A lot of them are fairly young, maybe less than 5 years old, 7 years old. You know, find out, what's going on and, and ask them the tough questions. And, if you hear something, let us know.
Sure. Absolutely. Yeah. If you
Okay.
can give me the numbers, I'll call
Yep.
Yep.
So, Mike or Randall, if you don't mind sending those numbers over and names, we'd love to make a few phone calls.
Yeah, in fact, I think Manchester might be one-stop shopping. The first project we did for them, I think, was chilled beam. And it was not net zero, but it was a chilled beam system. And then once they transitioned to net zero and we worked with CMTA, we did the ground source heat pump. So they've got both systems up and running. They've both all been running for several years now. So they would probably be good to talk about the pros and cons of the 2 different systems from their perspective in terms of maintenance and things like that.
Great.
Fantastic. Thank you. With that, is there any other questions, comments, thoughts that anybody wants to share with the rest of the committee?
Can we have Ben's presentation emailed to us, please?
Yes, Fran. Yep. We'll do that. We'll do that. Get that out to everybody.
Hey, Greg from Bismarck or TSKP. We just had a bid go out and come back in for a project in town, and it came in estimated with other people where they thought it might, but we might have missed it a couple years ago. We're like a couple $1 million short. Do you see anything in the market right now that's going to drive this up to? There might have been something said already in the Trumbull Times. I'm not sure if it's $1,000 per square foot. I don't know how to put that on this kind of building, but is that going to affect any drawings and future stuff going on here? What do you guys see? I mean, you guys are pulse on the market. I don't know. We just missed one real bad.
Well, I guess I'll start.
Yeah.
I'll go
let you guys
first.
go first.
So, I mean, the big unknown that everyone knows about is tariffs. That can have a huge impact on a lot of things. We don't know where that's going. And I want to say going back a year or so, I don't know when your estimate was originally or when it was originally budgeted, but there was really profound escalation in the market, going back 1, 2, and 3 years. I mean, really unprecedented escalation.
Yeah.
Our most recently projects that we estimated sort of during that period are now coming in under budget because they sort of come back to the norm a little bit.
Sure.
So, I mean, right now it seems like a more normal bidding climate to us. I
Okay.
don't know if that's what you're seeing, Greg.
You know, I could definitely confirm that. We just had a few bids roll in for Stanford over the past week, and we were under budget just on some little site packages, which is great to see. And something we also see in today's bid climate is we had guys all the way coming from New Haven down to Stanford, which you don't really see too often. It was just a really competitive bid market. So that's something good to see also.
Well, that makes us feel confident, and I guess we have the right people on board, I'm assuming. So that's a good. Thank you, guys.
Yeah, Kevin, we're going to keep a keen eye on the costs through every phase. So there's going to be a lot of discussions and meetings about the estimates and the scope and what the market is doing. But thank you for bringing that up. Any other comments or questions from anybody?
Yeah, I have one joke. If I could ask Greg.
Yep.
Greg, when you were seeing that favorable bidding of all these different contractors from other areas, is there a PLA on that project or not?
Not at the moment.
No.
No.
Okay.
Well, since we're working across the street, I can tell you that that client intends to move in that direction. So at least on our project, so that may affect yours as well.
Okay. If there's no other comments, I'd like to ask for a motion to adjourn.
Motion to adjourn.
Thank you, Fran. Any second?
Second.
Okay, that was a tie between Ann and was that JC?
Me.
No, that was Bill. Okay, thank you
Bill,
very
yeah.
much. All right, all in favor, say aye. Aye.
Aye.
Opposed? None. Okay, thank you guys very much. We'll see you
Okay,
on
good
the
night.
22nd. Appreciate everybody joining virtually. I think it worked pretty well. I think we'll do this again. All right.
Okay.
Good night, everybody.
All right.
Thank
Good night.
you.
Thank
Good night, everyone.
care.
Thank you.
Good night.
Good night.
Thank you.
Guys, thank you so much.